Hello. So this is a puzzle just to help you out on dividing by conjugates or dividing by complex numbers and dividing with square roots that have negatives inside of them. So let's take a look at this problem that's 2 divided by negative 5i. Notice that you have an imaginary number in the denominator. Whatever imaginary number in the denominator, you have to multiply by its conjugate. The conjugate is always the opposite of the imaginary part. So the conjugate of negative 5i is positive 5i. And whatever you multiply to the denominator, you have to multiply to the numerator. So in the numerator, you get 10i. And in the denominator, you get negative 25i squared. Remember that I squared is negative 1. So negative 25 times negative 1 is positive 25. So we have 10i over 25. And always look to see if you could reduce 10i over 25. They both divide by 5. So we get 2i over 5. If I take a look at the second problem underneath it that says 1 divided by 2 plus 3i, notice again that I have an imaginary term in the denominator. This complex number is 2 plus 3i. So I always want to multiply by its conjugate, which in this case is the opposite of the imaginary number, not the opposite of the whole thing. So it's going to be 2 minus 3i. And whatever I multiply to the denominator, I have to multiply to the numerator. So here in the numerator, I get 2 minus 3i. And in the denominator, if I do 2 things times 2 things, which is 4 things, or FOIL, I'm going to get 4 minus 6i plus 6i minus 9i squared. Remember that I squared is negative 1. So these denominators will cross out, and this negative 9i squared becomes positive 9. So now I have 2 minus 3i. In the denominator, I have 13. If I take a look at 3 minus 4i divided by 2 plus 5i, again, I have an imaginary term in the denominator. I have a complex, I have a complex number. And so anytime I have a complex number, I have to multiply by its conjugate. I'm going to write that problem further down because I've kind of taken up a little bit of room here. So 3 minus 4i over 2 plus 5i. So the complex conjugate of 2 plus 5i is 2 minus 5i. And when I do that, again, 2 things times 2 things is 4 things. You could either do the box method or do FOIL. I'm going to go ahead and do FOIL here. So 3 plus 2 is 6. 3 times negative 5i is negative 15i. Let me erase this and make it look a little better. I apologize. Sometimes that's how it is, right? You just kind of have to. So 3 minus 4i over 2 plus 5i. And again, I want to multiply by its complex conjugate, which is 2 minus 5i. So we have 6 minus 15i minus 8i plus 20i squared. And in the denominator, again, the box method or a FOIL, I'm going to get 4 minus 10i plus 10i minus 25i squared. Anytime you see an I squared, you're going to change it to negative 1. So 20i squared would be negative 20. And negative 25i squared is positive 25. and then I can combine like terms. So here, real numbers and real numbers, 6 minus 20 is negative 14. An imaginary number with imaginary number would be negative 23i. And the denominator, 4 plus 25 is 29. And then the 10 i's cancel out. So it answers negative 14 minus 23i all over 29. Now take a look at this one right here on the right. The square root of 32 plus the square root of negative 8, all divided by the square root of negative 72. Sorry, that's my son in the background currently dropping his toys. First thing you want to notice is you have a square root of a negative, and you can never, ever, 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 ever have a square root of a negative. So anytime you have a square root of a negative, the first thing you have to do is you have to rewrite it. So I need to rewrite this as the square root of 32 plus I square root of 8 over I square root of 72. Now, since they're all inside a square root, you always want to look to see what do they all have in common that it could reduce by. Okay, so if I look at 32, 8, and 72, I notice that they all divide by 8 inside the square root. And so when I do that, now I have the square root of 4 plus I square root of 1 over I square root of 9. Now I simplify each square root, so I get the square root of 4, which is 2, the square root of 1, which is 1, so this is I times 1, or 1i, and the square root of 9 is 3, so this is 3i. Now remember, you can't have an imaginary number in the denominator, so anytime you have an imaginary number in the denominator, you have to multiply top and bottom by its conjugate, which is negative 3i. And when you do that, you get negative 6i minus 3i squared over negative 9i squared. And every time you see an I squared, you replace it with negative 1. So this negative 3i squared becomes positive 3, and this negative 9i squared becomes positive 9. So I have negative 6i plus 3 over 9. And one last thing, what do you notice that all three terms have in common? Well, again, all three terms, they all divide by 3. So negative 2i plus 1 over 3. And of course, you don't normally put the negative 2i plus 1. You write it as 1 minus 2i over 3. I hope this was helpful. And if you need any extra help, remember I'm available Tuesday and Thursday from 3:15 to 4:15. Have a great day. Bye-bye.